All right, so today we're tackling time travel.
Oh, a classic.
Yeah, you sent over this stack of articles,
Right.
and it's everything. Wormholes, paradoxes,
Mm-hmm.
all the good stuff. Looks like you're trying to, I don't know,
Yeah.
bend time or something,
Maybe.
see the dinosaurs,
Yeah.
speed ahead to the future.
Who hasn't thought about it at some point, right?
Exactly. And you know what's funny?
What's that?
We actually already have a time traveler. Kind of.
Oh. I'm intrigued. Tell me more.
It's this cosmonaut, Sergei Krikalev.
Okay.
Spent over 800 days up in space.
Wow.
And because of that, Einstein's theories.
Right.
He actually shifted his timeline.
Yeah.
Just a fraction of a second, but still, he lived in the future.
That's wild. It's like proof that Einstein was onto something.
Right. Special relativity.
Exactly. It's like the faster you go, the slower time moves for you.
Compared to someone who's just, chilling on Earth.
Yeah, it's all relative, isn't it?
So theoretically, if we hopped in a spaceship,
Okay.
flew to, say, Betelgeuse.
That's, what, hundreds of light years away?
Something like that, yeah. Hundreds of light years. We could basically launch ourselves centuries into the future.
You could. But here's the catch. While you're out there zipping through space, hundreds of years would still pass back on Earth.
So you'd come back
To
to
a completely different world.
a totally different world. Okay, but hold on. That's to the future.
Right.
What about going back in time?
Ah, the Holy Grail.
Didn't Einstein say that was a no-go? At least at first.
So with special relativity, yeah, it seemed impossible. But then came general relativity, which brought gravity into the mix. And that's when things got really interesting.
Because that's where Kurt Gödel comes in.
Right.
With this idea that maybe, just maybe, time travel to the past wasn't completely out of the question.
Good old man. Brilliant, but definitely marched to the beat of his own drum.
Well, that's what it takes sometimes, right? To
Yeah.
really shake things up.
Totally. But to understand his idea, picture this. A giant cylinder, and you're traveling around and around it. Eventually, you'd get back to where you started, right?
Okay, I'm with you.
But in Gödel's model, you wouldn't just be back where you started, you'd be back in time. He called these closed timelike curves.
So it's like the cylinder itself is bending time.
Exactly. And his model of the universe, as strange as it might seem, showed that these closed timelike curves might actually be possible, at least mathematically.
So we just need to find us a giant time-bending cylinder.
Right. If we could create those curves, at least in theory, we might have a chance at traveling to the past. And physicists have been exploring all sorts of possibilities. Like, imagine these incredibly dense threads of energy called cosmic strings.
I've heard those.
Yeah?
They were like remnants from the very beginning of the universe, right?
Exactly. Some scientists think they could be used to create those closed, time-like curves.
Wow. Okay, and what about wormholes? Those are always a popular time travel topic.
Right. Those tunnels through space-time, connecting different points in space and time. Yeah, wormholes are a possibility, at least theoretically.
Okay, but theoretically and actually are two very different things, right? I mean, are wormholes even remotely possible in the real world?
That's the million-dollar question. Think of it this way. You're trying to fold a piece of paper so that two points that are really far apart touch.
Okay, I'm picturing it.
You'd have to bend or warp the paper, wouldn't you? Well, a wormhole would be like warping space-time itself, and that would take an unbelievable amount of energy.
Like more energy than we could ever even dream of creating.
Way more. We're talking about a type of energy we haven't even discovered yet, something called negative energy.
So it's not just about building a bigger spaceship. It's about fundamental breakthroughs in our understanding of physics.
Exactly.
Negative energy. Right, because warping spacetime is no easy feat.
Not at all. It's like the universe playing a cosmic game of Jenga.
And we're just figuring out the rules.
Exactly. And some physicists even think that the universe might have like built-in safeguards against time travel paradoxes.
Wait, really? Like a cosmic rule that says, no messing with the past.
Something like that. It's called the chronology protection conjecture. Basically, it suggests that the universe might have ways of preventing those paradoxes from happening. Maybe by making backward time travel impossible altogether, or maybe, well, there are other ideas out there too.
Well, now I'm even more curious about those paradoxes. Like, what about that classic one, the grandfather paradox?
Oh, you mean the one where you go back in time and accidentally prevent your grandparents from meeting?
Yeah. Does that mean you'd never be born?
Mm.
But if you were never born, how could you go back in time in the first place?
It makes my head spin just thinking about it.
Definitely a brain twister.
Hey.
But speaking of paradoxes and time travel, didn't Stephen Hawking try to test this whole thing out with a party? He did. That was brilliant, the time traveler party. So
Yeah.
he sends out the invites after the party, right?
Exactly. Figuring, hey, if anyone from the future wants to swing by, they'd already know about it.
It's the perfect plan. So did any time travelers show up?
Well, no one showed up to that particular party, but absence of evidence isn't necessarily evidence of absence, right?
True, true. I mean, maybe time travelers are just really bad at RSVPing.
Maybe. But, there are other theories about time travel out there, some even more mind-bending than wormholes and cosmic strings. Like, one of the articles you sent mentioned this wild idea by Gotten Live, these physicists who proposed that time loops might have been crucial to the universe's very beginning.
Right, the whole what if the universe is its own mother concept.
Exactly. Their model suggests that instead of this, linear progression of time from the Big Bang, there might have been a time loop way back at the very beginning, and this loop would have allowed the universe to essentially create itself. It's like a cosmic self-sustaining system.
So instead of something coming from nothing, we have the universe, like bootstrapping itself into existence.
It's a wild concept, right? And it kind of throws the whole Big Bang thing for a loop, literally.
Definitely a new way to think about the cosmos. But there are other models out there, right? I mean, some scientists still say the universe did come from nothing.
Yeah, there's Hawking's model and Vilenkin's, too. Both suggest the universe could have sprung from, well, nothingness.
Which is equally mind-blowing, if you ask me.
Oh, absolutely. I mean, it really highlights how much we still don't know about those earliest moments of the universe. It's like trying to solve a jigsaw puzzle, but with half the pieces missing.
And the pieces we do have keep changing shape.
Right. But even with all these mysteries, there are researchers out there looking for ways that time travel might be possible. And not just possible, but possible without creating those universe-breaking paradoxes.
Well, that's good to hear, because I'm not quite ready for the universe to implode on itself. But how do you even begin to address those paradoxes?
Well, one really intriguing solution came from researchers at the University of Queensland. Their work suggests that instead of time travel paradoxes destroying the universe, events would essentially recalibrate to maintain consistency.
Okay, now you're going to have to walk me through that one. So let's say, just for fun, that I did manage to travel back in time, and I prevented some major historical event from happening.
Okay, let's go with that. What kind of event are we talking about?
How about a pandemic? Let's say I stop a pandemic from ever happening.
Bold move. So you're saying you go back, change the past, and prevent this pandemic. Now, in a classic time travel paradox, this is where things would get messy. But according to their model, instead of the timeline falling apart, events would shift and adjust to accommodate that change you made. It's like the universe has a built-in autocorrect feature.
So I stomp the pandemic, and the universe goes, interesting, let's try this instead.
Exactly. Maybe some other event, something seemingly insignificant at the time, would end up triggering a similar chain of events, leading to a similar outcome. Or maybe the course correction would be more subtle, a series of smaller changes that ripple through the timeline, ultimately maintaining consistency.
So it's not really about changing the past so much as it is about understanding how everything is interconnected.
Right. And how even the smallest changes can have these ripple effects throughout history. It really makes you appreciate the complexity of time and the universe itself.
It really does. This whole conversation has me thinking, maybe the biggest breakthroughs we need aren't just about building faster spaceships or discovering new particles. Maybe we need entirely new ways of thinking about the universe, about time itself.
I totally agree. Einstein supposedly said that he only ever had 3 good ideas in his life. Maybe we're all just waiting for that next breakthrough, that fourth good idea that will revolutionize our understanding of time travel.
And who knows, maybe that breakthrough is just around the corner. But in the meantime, what are some of the biggest challenges that researchers are facing as they try to unravel these mysteries of time?
Well, we've touched on it a bit already, but I think the biggest hurdle is energy.
Right, because it's not just about finding a loophole in the laws of physics.
It's about harnessing enough power to actually make it happen.
Exactly. And like you said earlier, we're talking about levels of energy we can barely even imagine, let alone create.
Right now, it's just beyond our capabilities. And then, even if we could somehow solve the energy problem, there's the question of control.
Because a wormhole that collapses on itself isn't exactly a recipe for successful time travel.
Not unless you want to end up as, well,
A cosmic pancake.
something like that. We'd need a way to keep those wormholes stable, to make sure they actually led to the right place and time. It's an incredible engineering challenge, to say the
It
least.
sounds like we need some serious breakthroughs in physics before we start booking trips to the past.
We do. But that's part of what makes this whole field so fascinating, isn't it? Every new discovery, every theory we develop, it brings us a little bit closer to understanding these mind-blowing concepts.
It's true, the things we take for granted now, like electricity or the internet, people back then probably couldn't have even dreamt of.
Exactly. So who knows, maybe someday our understanding of time travel will seem just as primitive as, well, I don't know.
Like thinking the Earth is flat.
Exactly. But until then, we keep asking questions, keep exploring the possibilities, and who knows what we'll discover along the way.
Well, that's a perfect note to end on, I think. This whole conversation has been a wild ride through the world of time travel, with all its possibilities and paradoxes.
It really has. And for anyone listening who's ever dreamt of traveling through time, I think the biggest takeaway is this. Don't let go of that sense of wonder. Keep questioning, keep exploring, because who knows, maybe you'll be the one to unlock the secrets of time itself.
And if you do, you know where to find us. We'll be here ready to hear all about your time-traveling adventures. Until then, keep exploring.